Hello everyone, welcome to the lesson on energy and work done. Now, in this lesson, we will focus on energy. At the end of the lesson, you will be able to understand a little better what happens when energy is transferred. You will learn more about kinetic and potential energies. Let's recall what we have learned in the last section on work. Now, in the last section, we have learned that energy is the capacity to do work, which means that the more energy you have, the more work can be done. And when we are doing work, energy is actually transferred from one body to another. So in this example where the box is being pushed, so let's say you are pushing the box and the box moves a distance in the same direction of the force, we say that work is done. So when you are doing this work, you are actually transferring your energy to the box. So this is what happens. So when work is done, energy is transferred from the person that is exerting the force, or it could be an object that's exerting the force, to another object. So in this case, this is again an example that you saw in the previous chapter, a little boy pushing a trolley. So this boy pushes a trolley in this direction, and then the trolley moves here. So we say that the boy is doing work on the trolley. At the same time, when this trolley is moving and the boy is doing work on the trolley, the boy is also transferring energy to the trolley. The weightlifter, he is applying an upward force, and then the weight is also moved upwards. So in this case, we say that the weightlifter is actually doing work on the weights. And when she's doing that, she's also transferring her energy to the weight. So energy is transferred when work is done. So can you recall what are the types of energy around you? How many energies can you name? These are some of the common energies that you can see around us. Probably not nuclear energy, but the other 7 kinds of energy, you can see them all around you. You have to know these energies because in the later part of the chapter, you are going to learn how to convert from one form of energy to another. So let's focus on potential energy first. Now, potential energy simply means energy that is stored. The energy is stored inside a substance, and the energy can be released when this substance undergo a certain change. And there are 3 kinds of potential energy: chemical potential energy, elastic potential energy, and gravitational potential energy. We'll look at each of them in detail. So what exactly is chemical potential energy? Chemical potential energy is the energy that is stored in the chemical bond of a substance. Now, you have learned in set 1 that all substances are made up of atoms, and these atoms may be linked to one another by what we call a chemical bond. And this chemical bonds is where chemical potential energy is stored. So during a chemical reaction, these bonds may be broken. And when the bonds are broken, they may be rearranged or they may be broken forever. So during this process where the chemical bonds are broken, energy is given out, energy is released. And the chemical bond releases chemical potential energy because this is the energy that is stored in the chemical bond. So what kind of substances has chemical potential energy? Well, there are 3 main categories. Fuel has chemical potential energy. So when fuel could mean anything that can burn. So paper, candle, fossil fuel. So all these are examples of fuels. And these materials, when you burn them, what happens is during combustion process, these bonds are broken, and therefore the chemical potential energy is given out when you burn this fuel. It will be given out as heat and light, thermal energy and light. The other category of substances that has chemical potential energy will be the food that you eat. Now, when we eat the food after being digested, the energy is stored in our body, and during respiration process, this energy will be released. Again, there will be bonds that is present in our food, and these bonds will again be broken, and the energy will be released for our body function or for us to move around, so we can convert it to kinetic energy, for example. The last category will be batteries. Inside a battery, there are chemicals inside. So when we connect a battery to, let's say, a light bulb, and this is a full circuit, so the batteries chemicals inside the battery will start to react with one another, so there may be rearrangement of the chemical bonds and so on. We don't have to really be concerned about what's happening inside, but we do know there are chemical reactions, and the energy that's given out will be released as electrical energy. So when a battery is used, it's from chemical potential to electrical energy. The other category of potential energy is elastic potential energy. And elastic potential energy is energy that is stored in an elastic object that you have displaced. So it can be stretched, compressed, or deformed. So elastic object will be anything that you can, stretch and compress, and when you release the force, it will go back to its original shape. So a spring will be one example of an elastic object, a rubber band, and even the elastic band in a bowl. So all these objects, when you stretch them or you compress them, in that compressed and stretched state, there is elastic potential energy that's stored in it. Remember, if your rubber band is not being stretched, then there is no elastic potential energy. Just like your spring, if you do not extend it or if you do not compress it in its original state, then there is no elastic potential energy. But once you release the springs or you release your stretched rubber band, then they are able to do work. Remember, energy is the capacity to do work. So this elastic potential energy can do work. The last form of potential energy is gravitational potential energy. Now, this is the kind of energy that is stored in an object because of the object's position. Now, this object would be above the ground level. So let's say this is the surface of the Earth. So anything that is above the Earth's surface is said to have gravitational potential energy. So the higher the object, the more gravitational potential energy it has. So it depends on the height above the ground. So I repeat, the higher the object, the more gravitational potential energy it has. But does it mean that two objects that is at the same height, so let's say this object here, and I have another object here. So does it mean that these two objects, because they're at the same height, they will have the same gravitational potential energy? The answer is no, because there is another factor that will affect gravitational potential energy, and that is the mass. So even if the height is the same for both, if one object has a larger mass compared to the other object, then this object has a higher gravitational potential energy. So with that understanding, you can now take a look at the formula for gravitational potential energy. But before I move on to the formula, can I remind all students that gravitational potential energy is not to be confused with gravitational force. Gravitational force refers to the pull. Remember, a force is a push or pull, right? So gravitational force is the pull, how much the earth is pulling you down. But gravitational potential energy means how much capacity this object has to do work. Now, the higher it goes, the more work it is capable of doing. So you will have a higher gravitational potential energy. So do read the question carefully, whether they are referring to gravitational potential energy or gravitational force. So if you're asked to calculate gravitational potential energy, the formula is mgh. M stands for the mass. And just with other formulas that has mass in it, you need to remember that this has to be in the unit of kilograms. So if the question gives you the mass in grams, you have to remember to convert. G refers to gravitational field strength. And this is something that you should be familiar with in the chapter on mass and weight. So on Earth, if the question did not specify, we always assume that it is on Earth. And the value for G on Earth is 10 newtons per kilogram. So basically, it means every kilogram of mass, the Earth will pull it down with 10 newtons. So this is the value on Earth. The height, H stands for height. And do note that this height, we are referring to vertical height. So if let's say an object is somewhere here, then the height that we are referring to is vertically this way. So this is the height that we are referring to. Okay, it has to be vertically perpendicular. This height is perpendicular to the Earth. So the formula of mgh can be used to calculate gravitational potential energy, and we'll look at a few more examples to see how this formula can be used. Let's take a look at example 12. Now, in example 12, this lady, Janet, she's standing at the balcony with her husband. Okay, and the question says that the husband has a larger mass compared to Janet. So you are first asked to calculate the gravitational potential energy of Janet. So what we have to do, first of all, step one is always to write the formula mgh, and then we remind ourselves is the mass in kilogram. Yes, the question gives the mass in kilogram, so that's good. I don't have to do any conversion, so that's 50. And G, we assume that this is on Earth. Now, even if the question did not tell you the value of G, you are expected to know that the value of G on Earth is 10. So even if the question did not say, you are expected to know that it's 10. Then finally, what is the height? Well, the question says that the balcony, she's standing on the balcony, right? So the balcony is um, 15 meters. So 15 meters above the ground. So then that gives you the answer of 7,500 joules. So that's how you calculate gravitational potential energy. Write the formula, substitute, and then find the final answer in three significant figures. The next part of the question asks you to explain how does the husband's, so the husband is standing next to her, right? So how does the husband's GPE compare to Janet's GPE? So again, the key word that I want you to take note of is the word explain. So if you're asked to explain about gravitational potential energy difference, one thing that you have to do is to support your answer with the formula for gravitational potential energy. That's how you can get your full credit for your answers. So I need to support my answer by writing down the formula is mgh. And then I can go on to say that because they are both at the same place, so the G value will be the same. They are both standing at the same height, so the H is the same. So since the husband's mass is larger than Janet, then the gravitational potential energy of the husband will be larger than Janet's. So that's how you answer. Let's move on to the next question. Okay, so some nice tomatoes here. If a 10-gram tomato is 20 centimeters above the ground, what is its gravitational potential energy? Now, this is no difference from the previous question, except that you have to be a little bit more careful with the units. So you can see that the mass is given in grams, the height is given in centimeters. So you have to make sure you convert them to their respective SI unit. So the grams has to be in kilograms, cm has to change to meters. So this is what happens after conversion, and your answer is 0.02 joules. So what happens to the tomatoes gravitational potential energy when it drops to the ground? Well, if the tomato drops, so let's say this is the ground, when it drops to the ground, the height is going to decrease. So since GPE is mgh, so when the height decreases, then the GPE will decrease as well. And finally, when it reaches the level of the ground, then your height becomes 0. So that's when your GPE also becomes 0. So let's move on to questions on kinetic energy. Now, kinetic energy is the energy that an object has because of its motion. So sometimes kinetic energy is also known as movement energy. So any object that has a movement will have kinetic energy. So movement energy. And the kinetic energy increases with mass. So if you have two objects and they have the same speed, then the object which is bigger will have a larger kinetic energy, even though both of them has the same speed. So by the way, the symbol for writing speed in physics, we don't use letter S for speed, we use V. Okay, so V, actually it stands for velocity, but in Sec 2, I think we just take velocity to be the same as speed. Okay, when you are in upper sec, and then you will learn a little bit more about the difference between the two. But as of now, when you look at V, take it as speed. So if the two objects have the same speed, then the one with a larger mass is going to have a larger kinetic energy because the mass is larger. This one is a small mass, this is a big mass. So what if both objects have the same mass? Then it depends on the speed. So if this object moves with a small speed, this object moves with a large speed, then this is the one with a higher kinetic energy. So basically, there are two things that affect kinetic energy. Number one is the mass, and then is the speed. The formula for kinetic energy is half mv square. Now, I need you to be very, very careful with this square over here. We are not squaring half mv, we are squaring only the speed. So be very careful when you're pressing the calculator. So basically it is, so Ke is half times mass times, so V squared means V times V, right? So this is what it means. Okay, so a lot of students, when they do questions on kinetic energy, they quote the wrong formula, they forgot the square, or they write with the square, but when they press the calculator, they square the whole thing. So you have to be very careful. But if you are not sure, then you just type your calculator as half times m times v. Then you won't make a mistake. So some calculation examples. This is a car. The mass of the car is given. This is a very straightforward question. The speed is also given. So to calculate the kinetic energy, I first quote the formula and then I substitute the values. You notice how I put a square, put a bracket around the 20. Yeah, so 20 square. So my answer is 240,000 joules. So this is a straightforward basic question. Let's move on. This is a bullet, 40-gram bullet traveling at a speed of 350. Again, you should by now be very sensitive to units. So when you see grams, you know that you cannot substitute 40 into the formula because you have to use SI unit of kilograms. So there should be a conversion. So this is the conversion that you need to do. And your answer will be 2,450 joules. But since the question wants you to give your answer in kilojoules, then what you do is you divide by 1,000 to get 2.45 kilojoules. And this is the last question. Cyclist speed is given to be 4 meters per second and increases the speed to 10. So what is his increase in kinetic energy given the weight of the cyclist? Now, you cannot use the weight in half mv square, right? Because you need the mass. This is when you need to recall your formula. Weight is mg, W equals to mg. So with this formula, you calculate what the weight is so that we know that the cyclist has a mass of 80 kilograms. Then we start to look at this increase. Of course, you can calculate. Of course, you can calculate the kinetic energy. Half mv, half mass times 4 square, and then you calculate this kinetic energy half m times 10 square, and then you subtract. But I find that there's a shorter method. So this is the answer. So half m v square. Actually, there is a mistake here. You should, wait a minute. You should be All right. So let's continue with example 17. Now, for example 17, you are asked to calculate the change in kinetic energy when the speed changes from 10 meters, sorry, from 4 to 10 meters. Okay, let's carry on. Example 17. Now, for example 17, the cyclist is moving at 4 meters per second and increases his speed to 10 meters per second. So you're asked to calculate the increase in kinetic energy. Now, in this case, you do not, although we know the formula is half mv squared, but we do not know the mass. So you need to take the first step to calculate the mass first. So you know the weight, you know G, you can then calculate the mass. So W equals to mg will be the formula that you use, and you can get the the mass of the cyclist to be 80 kilograms. And then we go on. To calculate the increase in kinetic energy, there are two ways you can do it. Of course, one way is to calculate the kinetic energy, the initial kinetic energy, which is half m v square, and then you can calculate this is the initial kinetic energy, and then you can calculate the final kinetic energy, which is a half m v square. Or you can also do it this way. You can take half m, then you can take 10 square minus 4 square. Now this is when I want you to be very, very careful. The If you want to do this shorter method, you can take 10 square minus 4 square, but you cannot do this. You cannot say that it is half m 10 minus 4 square. Now, this is different. This you will get a different answer compared to this one. So this is the wrong method because you can subtract the square of the speed, but you cannot square the differences in speed. But if you're unsure of how to do it, then the safest method is to calculate the initial, calculate the final, and then you can just subtract. Okay, so we have come to the end of the chapter on on energy. You can watch the next video to learn more about energy conservation. So the next video is on energy conservation, what happens about when energy is converted, what happens when energy is transferred, and then that will be the last video for this series of lesson. All right, so thank you for your attention.